Special triangles from geometry. You might remember there are a couple of triangles where the sides are related to each other in a particular way. The first one is the 45-45-90 triangle. In other words, a triangle where there is a right angle and where the other two angles are each 45 degrees. Well, since these two angles are the same, we know that the lengths of the sides opposite those angles must also be the same length. In other words, if this is x units long, then this leg will also be x units long. What about the hypotenuse of this triangle? Well, we can figure that out using the Pythagorean theorem. If I square the first leg and I square the second leg, and I add those up, that will be the hypotenuse. We usually call that c, the hypotenuse squared. Let's solve for c. This gives me 2x squared equals c squared. Square root each side. Since x squared is a perfect square, I can take that out of the square root, leaving me with c is equal to x times the square root of 2. This picture is so important. What we're saying is if you have any 45-45-90 triangle, the two legs will always have the same length, and the hypotenuse will be square root of 2 times as much as the length of one of the legs. Okay, 30-60-90 triangle. That's a little more complicated because now all three sides have different lengths. This would be the triangle where there is a right angle. The smallest angle would be 30 degrees, and the medium angle would be 60 degrees. Well, let's call the side opposite the 30-degree angle x. That would be the shortest side since it's across from the smallest angle. It's not too difficult to figure out the hypotenuse this time, which would be the longest side. That is because this 30-60-90 triangle, one way to think of how it was created was that it's simply half of an equilateral triangle. An equilateral triangle means all the sides are the same length and all of the angles measure 60 degrees. Well, it's not too difficult to see that this line here cuts in half that bottom segment. So if this is x, then this must be double x, in other words 2x, and that means this is 2x and this is 2x because of the equilateral triangle. So the longest side is twice as much as the shortest side in the 30-60-90 triangle. What about the medium side, the side across from the 60? Well, again, I can use the Pythagorean theorem. The first leg squared plus, I'll call that second leg b, the second leg squared is equal to the hypotenuse squared, just applying the Pythagorean theorem. That gives me x squared. I'm going to try to solve for b. Plus b squared equals 4x squared, 2x times 2x. Subtract x squared from each side. I get b squared equals 3x squared. Again, square root, and I'm left with that x comes out again, x times the square root of 3. That's the length of the medium side. So in a 30-60-90 triangle, if you call the short side x, the medium side is root 3 times as much as that, and the long side is double, 2 times as much as x. Again, these two pictures, very important to memorize, to know backwards and forwards. The simplest version of these two pictures, for the 45-45-90 triangle, the simplest one would be the situation where x is 1, and then you have 1, 1, and the square root of 2. For the 30-60-90 triangle, the simplest situation would be the situation, again, where x is 1. That would make the medium side square root of 3 and the long side 2. We'll probably use these pictures just as often, if not more often, than the original pictures. It's important that you learn and memorize these relationships. We will use them a lot as we get into trigonometry. Thanks for watching.